In today's world, mathematical knowledge is one of the most important gatekeepers, and demonstrating good mathematical understanding opens the doors to better work and financial opportunities, and can lead to better health and civic engagement. In Victoria, there are several state government policies that aim to lift the standards of mathematical education, the latest of which is the Middle Years Literacy and Numeracy Support Initiative, which aims to identify students at risk of finishing school without literacy and numeracy skills and providing them with individual teacher support. The lesson presented in this video could be offered to remedial students as part of the Middle Years Literacy and Numeracy Support program, and could be taught to students in a class setting or as a blended online learning environment. The topic being covered is the Level 9 Measurement and Geometry Unit, Calculate the Area of Composite Shapes. However, like most mathematics teaching, it is linked to other strands, substrands, and levels. For instance, learning about composite shapes begins at level 4, and the formula for area is taught at level 7. Learning about area is of course a precursor for learning about volume, which is studied more deeply in Year 10 and into VCE. The lesson itself has been designed to give students lots of opportunities to engage with the material, and has been planned with elements from the Victorian Education Department's High Impact Teaching Strategies, or HITS, which are evidence-based practices that have been shown to increase student learning, such as setting goals, differentiated teaching, and collaborative learning. The whole lesson is student-centered and takes the social constructivist approach to learning, where engagement and participation is key. It is the opposite of traditional mathematics, moving away from textbooks and explicit teaching of algorithms and formulas. Active learning is essential, and students are to discover and rediscover formulas themselves, completing tasks that build on prior knowledge. This lesson takes the view that all students are able to complete tasks successfully if they are given the right guidance and strategy. There are of course elements of teacher-led learning, but most is constructed by the students, with the scaffolding of prior learning geared towards new concepts. This approach internalizes the learning and ensures that students are able to have a better understanding and gives them confidence in their ability for work in the future. A holistic approach has been taken, with students given an opportunity to engage with the lesson via an online task even before the lesson begins. The task is to get students ready to learn by giving them something to connect with when in class. The actual lesson starts with a brief overview and a discussion of the learning outcomes, with a description of what success in the unit looks like, as well as discussing routines and strategies students can use to get to the learning goals, such as active participation and asking questions. As Hattie and his colleagues say, if students know where they are going and how they'll know when they get there, they are better able to set their own expectations, self-monitor and predict, or self-report their own achievement. This statement powerfully encapsulates what can happen when students are in control of their learning and sets the tone for the lesson. To introduce the main content of the lesson, the teacher draws upon the student's prior knowledge and makes it all relevant by discussing the mathematical links to the real world. This takes the learning out of the realm of mathematical abstraction and puts it into practical usage, which makes what is to be learnt more applicable and interesting. In addition, by leveraging prior knowledge, the teacher will more easily be able to link new knowledge by not overburdening the student's cognitive resources. Area is content learnt as early as level 2, and by the middle of primary school, students are counting squares in shapes. The basic area formula multiplying length and width of a rectangle is established in level 7. However, in Year 9, this concept may still be an area of confusion, especially if this is coupled with learning about converting different units of measurement, for example, converting between millimetre, centimetre, metre and kilometre. Research shows that this issue is one of the major areas of misconception. This topic is generally learnt in Year 8. However, at Level 9 it may still be an issue. To demystify this matter, the teacher can use visual models to demonstrate that area can exponentially grow when converting between small and big units. The teacher can show that 1 centimetre square is not 10 millimetre square, but 100 millimetre square, and 1 metre square is not 100 centimetre square, but 10,000 centimetre square. To ensure that the concept is well understood, the teacher can get the students to draw their own rectangles of various sizes, with scales that are in millimetre square, centimetre square, and metre square. When students learned about the area of rectangles in Level 7, they would have also learnt about the area of triangles and parallelograms. However, like converting between units of measurements, the concept of finding the area of a triangle may still be an issue in Level 9, since triangles are not as easy to grasp straight away compared to rectangles and squares. There are also many different types of triangles too, so students may think there are different formulas for different triangles. The teacher can immediately discuss the area of a triangle by initially focusing on the rectangle previously worked upon. A line can cut a rectangle in half diagonally for students to infer that the area of a triangle is half a rectangle. The teacher should allow the students to give an explanation and come to their own conclusion. This could be done as a whole class discussion or with individual students. Reeve and Waldecker say that this think aloud method is useful for teachers as it helps to determine specific weaknesses, specific error patterns, or the use of inappropriate strategies, and can help the teacher determine ways to address it. The teacher can then give this problem-solving question from the NAP plan for students to solve in pairs. More able students may be paired with less able students, and students with strong language skills may be paired with students with weak language skills. This dialogue between a peer will allow for deeper learning, as students have to come to an agreement using the language of mathematics. Once students have their answers, they can give their explanation to class on how they solved the problem and why the other answers are wrong. Students may eventually conclude that the area of a triangle is half the base times height. This construction of a formula will allow the students to develop a sense of ownership or agency which allows them to recall it more easily when needed in the future. To ensure students have a thorough understanding that a triangle is half a quadrilateral, the teacher can show this short YouTube video which demonstrates how congruent triangles are made when the base is replicated at the height to form rectangles. The teacher can then get students to create their own congruent triangles as they observed in the video by providing students with paper, ruler and pencil. This could be set as a differentiated task by having a variety of triangles such as the obtuse, acute, isosceles, equilateral and scalene triangles. A differentiated task is of course a low floor, high ceiling activity where all students can access, but can be extended higher depending on the student's ability. This is an optimal strategy for most classroom environments and ensures that all students are working in the zone of proximal development, as identified by Vygotsky. When students are challenged at the right level, they generally have the ability to grow their learning much more than if it was set too high or too low. To reinforce the understanding of area further, the teacher can give students a short exercise to find the area of several triangles. By this stage, students should have a good understanding of finding the area of both triangles and rectangles, which allows the teacher to scaffold onto the main concept, which is to develop problem-solving strategies to partition composite shapes into learnt shapes. Students can be given two related online exercises that test the students' visual skills in seeing shapes within composite shapes. The first exercise is to move squares and rectangles into a composite shape, and the next exercise is to find the area of the composite shapes with the measurements given. Both exercises could be done in pairs to enhance communication skills again, and could be extended for students to find alternative methods and ways of solving the problem. At the end of each exercise, a discussion could be had with students sharing their strategies and methods used to solve the problem. The final exercise is an open-ended task for students to consolidate all they have learnt from the lesson. The final task allows the students to opt in at the level they are most comfortable with and produce work that will enhance their growth. The lesson could be extended further with more emphasis on different units of measurements, which, as mentioned, is often an area of confusion and misconception. Then find the area. Students should draw their letters on a grid piece of paper, then show their working out of the area on the side. Alternatively, students could draw block letters and allow their classmates to find the area. Less able students may be given easier letters, and more able students may be given more difficult letters to find. As a further challenge, the teacher can set limits to the number of squares for each letter, for example 15 square centimeters. In this instance, students are made to think of strategies which will further enhance their understanding of area within composite shapes. All this work can be collected by the teacher and used as formative assessment. This should be returned to students as promptly, with feedback about the process and not just the task. This will move students from surface learning to deep learning. Errors should be noted to the student, and they should have a chance to address them as opposed to supplying correct and incorrect answers. The closing part of the lesson has the teacher recapping what has been learnt and getting the students to reflect on their own learning. The teacher can point out specific metacognitive strategies used, such as visualization of shapes within the shapes, inference, and self-instruction. This attitude helps the students develop critical and creative thinking skills and allows students more easily connect old and new concepts when attempting different tasks in the future. This concludes my presentation of a research lesson that caters to remedial students learning measurement and geometry. It started with learning the way to find area of simple shapes, which allowed students to tackle the area of more complex shapes. Although this lesson is designed for students in Year 9, the content could easily be modified for both higher and lower level students.